The sun. It's big, it's bright, it's essential for life. Without the sun, our planet would be a frozen, lifeless rock. This giant ball of gas is the center of our solar system. It holds everything together with its gravity. Planets, asteroids, comets, they all orbit the sun. The sun provides us with light and warmth. It drives our weather patterns and seasons. It's the ultimate source of energy for almost all life on Earth. In this exploration, we'll journey into the heart of our star. We'll uncover its secrets and understand its profound impact on our cosmic neighborhood. The sun's story begins billions of years ago. Imagine a vast cloud of gas and dust, a nebula, drifting through space. This cloud was the birthplace of our sun. Over time, gravity pulled this cloud together. The cloud became denser and hotter. Eventually, the pressure and temperature at the center became so intense that nuclear fusion ignited. This fusion process, where hydrogen atoms combined to form helium, released an incredible amount of energy. And so, our sun was born. Deep within the sun lies its core. This is where the real action happens. The core is a scorching hot place, with temperatures reaching millions of degrees. It's under immense pressure too, from the weight of the sun's outer layers pressing down. These extreme conditions are perfect for nuclear fusion. Every second, millions of tons of hydrogen are converted into helium in the sun's core. This process releases a tremendous amount of energy in the form of light and heat. This energy slowly makes its way outward, eventually reaching the sun's surface and radiating out into space. Surrounding the core is the radiative zone. This region is so dense that energy from the core takes hundreds of thousands of years to travel through it. Imagine a crowded room where you're trying to move but keep bumping into people. That's what it's like for energy trying to escape the radiative zone. The energy bounces around, getting absorbed and re-emitted by atoms countless times. This process gradually shifts the energy toward the sun's surface. It's a slow and arduous journey, but eventually the energy escapes the radiative zone and enters the next layer, the convective zone. Section 5. Convection's churn, the sun's boiling surface. The sun, our closest star, is a massive ball of hot plasma, and its surface is a fascinating place of constant activity and movement. In the convective zone, the sun's energy finally gets a move on. This zone is a turbulent region where energy, in the form of heat, is transported outward by the movement of plasma. Think of a pot of boiling water. The process happening in the sun's convective zone is quite similar to what you see when water boils on your stove. Hot water rises to the surface, cools as it releases heat, and then sinks back down, creating a rolling boil. This continuous cycle is driven by temperature differences. The convective zone operates in a similar manner. Here, hot plasma rises towards the sun's surface, cools down, and then sinks back into the depths, only to be reheated and rise again. Hot plasma rises to the surface, cools, and sinks back down. This process is continuous and creates a dynamic, ever-changing surface. This creates a churning effect, much like the boiling water. The sun's surface is in constant motion, with plasma moving up and down in a never-ending cycle. This churning is visible on the sun's surface as granules. These granules are essentially the tops of the convective cells, where hot plasma reaches the surface. These are bright spots where hot plasma is rising. They're incredibly bright and can be seen as small bright patches on the sun's surface. They're surrounded by darker areas where cooler plasma is sinking. These darker regions are where the plasma has cooled and is descending back into the sun's interior. The convective zone is the final stage of the sun's energy transport system. After energy has been generated in the core and passed through the radiative zone, it reaches the convective zone. From here, energy is radiated out into space, lighting up our solar system. This energy is what makes life on Earth possible, providing the light and heat necessary for our planet's ecosystems to thrive. The sun's boiling surface is a testament to the incredible processes happening within our star, processes that have been ongoing for billions of years and will continue for billions more. Understanding these processes helps us appreciate the complexity and beauty of the sun, our life-giving star. Section 6. The sun's atmosphere, corona and solar wind. The sun's atmosphere is a wild and dynamic place, full of fascinating phenomena and intense energy. It's composed of several layers, each with its own unique characteristics and behaviors. These layers work together to create the sun's complex and ever-changing environment. The chromosphere is a thin layer of gas above the photosphere, the visible surface of the sun. Despite its thinness, it plays a crucial role in the sun's overall structure and activity. It's here in the chromosphere that we witness spectacular solar flares, which are sudden bursts of energy and light. These flares can release as much energy as billions of atomic bombs. Above the chromosphere lies the corona, the outermost layer of the sun's atmosphere. The corona extends millions of kilometers into space and is visible during a total solar eclipse. The corona is much hotter than the sun's surface, with temperatures reaching up to several million degrees Celsius. This extreme heat is still a subject of scientific research and curiosity. The corona is also the source of the solar wind, a continuous stream of charged particles that flows out from the sun. These particles travel through space at incredible speeds, influencing everything in their path. This solar wind affects planets and other objects in the solar system, including Earth. It interacts with Earth's magnetosphere, creating phenomena such as the auroras, and can even impact satellite operations and power grids. Section 7. The Sun's Influence, Earth and Beyond. The Sun's influence extends far beyond its visible surface. Its gravity holds the solar system together, keeping planets in orbit. The Sun's energy provides light and warmth to Earth, making life possible. It drives our weather patterns, ocean currents, and climate. The Sun's magnetic field also interacts with Earth's magnetic field, creating the aurora borealis and aurora australis, stunning displays of light in the sky. But the Sun's influence isn't always benign. Solar flares and coronal mass ejections can disrupt satellites, power grids, and communication systems on Earth. Section 8. Solar Surprises, Unveiling the Sun's Secrets. Scientists are constantly learning new things about the Sun. Spacecraft like the Parker Solar Probe and the Solar Orbiter are providing unprecedented views of our star. These missions are helping us understand the Sun's magnetic field, the solar wind, and the processes that drive solar flares and coronal mass ejections. One surprising discovery is that the Sun's corona is much hotter than its surface. This has puzzled scientists for decades, and we're still trying to figure out why. Another mystery is the Sun's 11-year cycle of activity. During this cycle, the number of sunspots, solar flares, and coronal mass ejections increases and decreases. Section 9. The Sun's Fate, a glimpse into the future. The Sun won't last forever. It's a sobering thought, but one that reminds us of the ever-changing nature of the universe. Like all stars, it has a limited lifespan. Stars are born, they live, and eventually they die. The Sun is no exception to this cosmic rule. But don't worry, it still has about 5 billion years left. That's a long time, much longer than the entire history of human civilization. As the Sun ages, it will gradually run out of hydrogen fuel in its core. This process is slow but inevitable, a natural part of a star's life cycle. Eventually, the core will contract and heat up, causing the Sun to expand into a red giant. This transformation will be dramatic and awe-inspiring. When this happens, the Sun will engulf Mercury, Venus, and possibly even Earth. The inner planets will be consumed by the expanding star. Our planet will become uninhabitable long before then. The increasing heat and radiation will make life on Earth impossible. Finally, the Sun will shed its outer layers, leaving behind a white dwarf, a small dense remnant of its former self. This white dwarf will be the final stage of the Sun's life. This white dwarf will slowly cool over trillions of years. It will no longer produce light or heat, becoming a cold, dark remnant. So while the Sun may be the star of our show today, even stars have their curtain call. The end of the Sun's life will be a quiet, gradual fading away. But until then, let's appreciate the warmth and light of our cosmic powerhouse. The Sun gives us life, energy, and a sense of wonder. Let's cherish every moment under its golden rays.